It is indeed possible for an electrical inspector to request a generator backfeed during a final electrical inspection. This is typically done to verify the proper operation of all electrical systems within the building. During a final inspection, the inspector needs to confirm that the main electrical panel, grounding system, and all lighting fixtures are functioning correctly. Backfeeding with the generator provides a temporary power source that allows the inspector to assess these systems in a controlled manner. Here is a breakdown of the process. Firstly, the electrician isolates the main power to the building by disconnecting it from the utility grid. This is a critical safety step to prevent any backflow of electricity onto the grid, which could be hazardous for utility workers. Secondly, the generator is installed. A portable generator is typically placed outside the building and connected to the main electrical panel via a special transfer switch. This transfer switch is essential because it prevents the generator's power from feeding back into the utility grid, and vice versa. Thirdly, the generator is backfed into the electrical panel. The electrician starts the generator, and power is then sent into the electrical panel. This energizes all the electrical circuits within the building, effectively replacing the utility power with generator power. Fourthly, the electrical inspection occurs. With the generator providing power, the inspector can conduct a thorough examination of the electrical system. This includes checking the voltage and amperage at various points, testing the functionality of outlets and switches, and verifying the proper operation of lighting fixtures and appliances. The inspector will also ensure that the grounding system is correctly installed and functioning. Fifthly, the generator backfeed is removed. Once the inspection is complete and the inspector is satisfied that the electrical system meets all code requirements, the electrician will disconnect the generator and restore the utility power to the building. It is crucial to emphasize that backfeeding a generator requires specific expertise and adherence to strict safety protocols. It should only be performed by qualified electricians who are familiar with the equipment and the applicable electrical codes. Here are some key safety precautions to consider. Firstly, the use of a transfer switch is paramount. A transfer switch physically isolates the generator from the utility grid, preventing the possibility of backfeeding electricity onto the grid. This is a critical safety measure to protect utility workers and prevent damage to electrical equipment. Secondly, proper grounding is essential. The generator must be properly grounded to prevent electrical shock hazard. This typically involves connecting the generator's grounding terminal to a grounding rod or to the building's grounding system. Thirdly, all electrical connections must be made correctly and securely. Loose or faulty connections can create a fire hazard or cause electrical shock. Fourthly, the electrician must follow the manufacturer's instructions for the generator and the transfer switch. These instructions provide specific guidance on the safe and proper operation of the equipment. Fifthly, the electrician must comply with all local building codes and electrical regulations. These codes are designed to ensure the safety of electrical installations and prevent electrical hazards. The National Electrical Code, or NEC, provides comprehensive guidelines for electrical installations. Article 700(1) through 700.12 covers emergency systems, including generators. Article 701.1 through 701.11 covers legally required standby systems, while Article 702.1 through 702.13 covers optional standby systems. Each of these articles outlines specific requirements for the installation, operation, and maintenance of generator systems. NEC Table 220.42 provides guidance on calculating feeder demand factors for various types of loads, including lighting, appliances, and motors. This is important for determining the appropriate size of the generator to meet the building's electrical needs. NEC Section 250.20 specifies the requirements for grounding electrical systems. This includes the size and type of grounding conductors, as well as the methods for connecting the grounding system to the earth. NEC Section 310.15 details the allowable ampacity of conductors, which is the maximum current that a conductor can safely carry without overheating. This is important for selecting the appropriate size of conductors for the generator circuit. NEC Section 445.11 provides requirements for the overcurrent protection of generators. This includes the use of circuit breakers or fuses to protect the generator from overload and short-circuit conditions. When a generator is used as a temporary power source, several factors must be considered to ensure safety and proper operation. These factors include the size of the generator, the type of fuel used, and the location of the generator. The size of the generator must be sufficient to meet the building's electrical load. This can be determined by calculating the total wattage of all the appliances and equipment that will be powered by the generator. It's also important to consider any surge currents that may occur when appliances or equipment are first turned on. The type of fuel used by the generator can also affect its safety and performance. Gasoline generators are typically less expensive than diesel generators, but they can be more prone to fuel-related problems. Diesel generators are more fuel efficient and reliable, but they tend to be more expensive. The location of the generator is also an important consideration. Generators should be placed in a well-ventilated area to prevent the buildup of carbon monoxide, which is a deadly gas. Generators should also be protected from the weather to prevent damage to the equipment. In addition to these factors, it's important to follow all manufacturers' instructions for the generator and the transfer switch. These instructions provide specific guidance on the safe and proper operation of the equipment. If you are not comfortable working with electricity, it's best to hire a qualified electrician to install and operate the generator. Here's a more detailed look at the steps involved in backfeeding a generator. Firstly, isolate the main power. This involves disconnecting the building's electrical system from the utility grid. This is typically done by turning off the main circuit breaker in the electrical panel. However, it's important to verify that the power is completely disconnected before proceeding. Secondly, install the transfer switch. A transfer switch is a device that allows you to safely switch between utility power and generator power. The transfer switch should be installed by a qualified electrician in accordance with the manufacturer's instructions and local electrical codes. Thirdly, connect the generator to the transfer switch. This involves connecting the generator's output terminals to the transfer switch's input terminals. It's important to use the correct size and type of conductors for this connection. Fourthly, start the generator. Follow the manufacturer's instructions for starting the generator. Be sure to allow the generator to warm up before applying a load. Fifthly, switch to generator power. Once the generator is running and warmed up, you can switch the transfer switch to the generator position. This will disconnect the building's electrical system from the utility grid and connect it to the generator. Sixthly, monitor the generator and the electrical system. It's important to monitor the generator's voltage and frequency to ensure that it's operating within its specifications. You should also monitor the electrical system for any signs of problems, such as flickering lights or tripped circuit breakers. Seventhly, switch back to utility power. When the utility power is restored, you can switch the transfer switch back to the utility position. This will disconnect the building's electrical system from the generator and reconnect it to the utility grid. Eighthly, shut down the generator. Follow the manufacturer's instructions for shutting down the generator. Be sure to allow the generator to cool down before storing it. The temporary power provided by the generator backfeed allows the inspector to thoroughly check the wiring, connections, and overall functionality of the electrical system under load. This is a more comprehensive assessment than simply visually inspecting the components. By observing the system in operation, the inspector can identify potential problems that might not be apparent during a static inspection. For example, the inspector can check for voltage drops, overheating wires, or faulty connections. They can also verify that the grounding system is properly functioning and that all safety devices, such as ground fault circuit interrupters or GFCIs, are working correctly. In summary, while backfeeding a generator for an electrical inspection might seem unusual, it is a legitimate practice that allows for a more thorough assessment of the electrical system's functionality and safety. However, it's imperative that this procedure is performed by qualified electricians who adhere to strict safety protocols and comply with all applicable codes and regulations. Remember, safety should always be the top priority when working with electricity.